Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we solve the numerical which is based on the internal combustion engine, and it's a very simple, easily we can able to calculate the required parameters, and it's a very important for the examination point of view. So easily we can score the marks in this kind of problems here. So now let's just look into the problem here, what he has given in the data. So he has given that, so it's a single cylinder 4-stroke engine is given. It's a single cylinder 4-stroke engine, and he has given the diameter of the bore, it's a 180 mm is given. So I have taken in terms of the meter, so which is of 0.18 meter. So because we just try to convert in terms of the meters here, so that the required parameters easily we can calculate, and we can get in terms of some kilowatts or etc. Okay, now again he has given the stroke, that is the distance between the top dead center to bottom dead center. So that is a stroke. He has given as a 200 mm is given, so it's a 0.2 meter I have taken. Now he has given the shaft, like a speed of that particular engine. Okay, speed of that is a 300 rpm. It will be rotates in a 300 revolutions per minute. Now which is developed a torque of 200 Newton meter. The torque he has given 200 Newton meter. So as well as the mean effective pressure which is developed inside the combustion, inside the cylinder is 6 bar is given, as well as the mass of the fuel, like a mass of the fuel consumption is a 4 kg per hour is given, and again he has given the calorific value of that particular fuel is 42,000 kilojoule per kg. Okay, now these are the basic data what he has given in this problem entire thing. Okay, now we have to find out what will be the indicated power, brake power, frictional power, mechanical efficiency and thermal efficiency, etc. Now how to calculate this? We just go through one by one here. Now we just have to calculate the indicated power. So indicated power, the formula is, you can take x plan by 60 into 1000 I will take here. So this one I will take as a n dash here just for the representation. Now we just go through what is x, p, l, a, n dash in a proper here. So x indicates it's a number of cylinders. So he has given that it's a single cylinder means, so small x I have just represented here, it's a number of cylinder. I will just take this is a 1. So P is nothing but it's a mean effective pressures. So but in this formula we have to take this P as in terms of Newton per meter square. So this 6 bar I can write it as 6 into 10 power 5 Newton per meter square. So because for 1 bar is nothing but it's a 10 power 5 Newton per meter square. So 6 bar becomes a 6 into 10 power 5 Newton per meter square. I will just take here 6 into 10 power 5. Now the length, that is a stroke. So he has given a 0.2 meter. I just take it's a 0.2 meter. Now this is the area of a cylinder is given. So he has not given the directly the area, but we know that the diameter of a bore is it's a 0.18 meter. So but area becomes pi d square by 4. I will just take here pi into 0.18 square by 4, that gives the area of a cylinder, and this n dash is nothing but, okay, so for 4 stroke, so for every 2 revolutions we are going to generate the power. Okay, so similarly this is the speed is given, actually the speed is given, that is a 300 rpm, that's a capital N here, but this n dash is nothing but it's a n by 2 we have to take for 4-stroke engine. It's a 300 by 2, and this will be the 60 into 1000. So when we simplify this, we are going to get the indicated power in terms of the kilowatt taken. But in case of the 2-stroke engine, this n dash is nothing but the actual speed what he has given. Okay, directly it's a 300 in case of 2-stroke. Okay, now for this, the what I am getting the indicated power is, I will get in terms of the kilowatt, because that's why I have taken the 1000 here, so that it will be the value what I am getting here is in terms of kilowatt. Now just I have a look here. So it's a the what we are getting the value of indicated power is 7.634 kilowatt. Okay, now this is what the indicated power. Now we just move on to the second thing is what, it's a brake power. Okay, now let us move on to the, we will just calculate what is the brake power here, that is the second one. So brake power is equal to we will be having 2 pi nt by 60 into 1000. So in this case, so here the n is nothing but directly it's a 300 rpm what he has given the speed of the engine. We should not take the 300 by 2 or something, okay, that is indicates it's a n dash. So this is our 2 pi 300 and this is our torque he has given, that is a 200 Newton meter. This is 60 into 1000. So I'll get the brake power here. So this is the actually the power which we are getting for the external usage, okay. Indicated power means this power what we have generated because of the combustion of the fuel inside the cylinder, but this is the what is the actual, this is the power, actual power we are getting at the with the help of the crankshaft here, okay. Now the brake power what I am getting here is it's a 6.283 kilowatt, okay. Now when you just simplify this, I am going to get the 6.283 kilowatt here. Now the third one what we have to find out here is a frictional power. So frictional power is nothing but it's something like, okay, it's a difference of the indicated power to the indicated power and the brake power here. So frictional power is equal to, I can take indicated power minus brake power. So this frictional power is something like it's a losses due to the friction between the parts here, okay. Now this indicated power is our 7.634 and in brake power is our 6.283. Just simplify, we will be getting a frictional power. The value is 1.351 kilowatt, okay. Now we just move on to the next term over here. The next thing is we have to find out the mechanical efficiency. So we will just try to find out the fourth one. I just take the mechanical efficiency which is given by brake power by indicated power, okay. This will give the mechanical efficiency here. So brake power gives it's around 6.283 and indicated power is over 7.634 into 100. We just calculate this mechanical efficiency, that gives the value here. So mechanical efficiency we are getting around, it's a 82.3%. Now this is our fifth one, is we need to find out the indicated thermal efficiency, brake thermal efficiency, etc. So we just calculate indicated thermal efficiency. Now the indicated thermal efficiency, the formula which gives, so it's a ratio by indicated power and this is the heat supplied, that is the mass of the fuel into calorific value. We just multiply here for the percentage here. Now very important thing is, so this mass of the fuel we have to substitute in terms of the kg per second here. So this indicated power is, as usual, it's a 7.634 kilowatt. So mass of the fuel is, it's a 4 kg, we know that 4 kg per hour, but when we convert in terms of the second, it's a 4 by 3600 seconds, that is a 4 by 3600, and this calorific value is our 42,000 here, and this will be the as usual. Now we just calculate, this is our indicated thermal efficiency. So the value is what you are getting is 16.37%. So this is our indicated thermal efficiency. Now let us move on to the brake thermal efficiency. So the brake thermal efficiency I can take as, it's a ratio by BP by MF into CV. So similarly the same formula is there, only instead in place of BP and okay, if it is a brake power, brake thermal efficiency, we just substitute the brake power. If it is a indicated thermal efficiency, we just take the numerator as a indicated power. So now brake power is 6.283, and again here also the same thing, the mass of the fuel what it consumes is kg per second. I'll just take the 4 by 3600. This is our calorific value into 100. So we'll be getting the brake thermal efficiency here. So value is around 13.48%. So this is our brake thermal efficiency. Okay, I hope you are getting this one. Now the last part is that is the brake specific fuel consumption. The last one is brake specific fuel consumption is given by, it's a MF by BP. There's a small difference over here. You just see here it's a BP by MF is there, but small thing. So but when you are calculating the brake specific fuel consumption, so it's a ratio of mass of fuel by BP here. Now but here in this case the mass of the fuel is in terms of kg per hour itself. We just take here it's a 4 kg and the brake power is 6.283. We just simplify this, we are getting around the value is 0.63. The unit becomes, it's a kg per kilowatt hour, because this is in terms of kg per hour. So this power is in terms of a kilowatt here. So the unit becomes kg per kilowatt hour. So which gives the brake specific fuel consumption here. I hope you are getting this concept here to calculate the indicated power, brake power, frictional power, indicated thermal efficiency, brake thermal efficiency, and okay, this is a brake specific fuel consumption. So indicated thermal efficiency is what it's a, okay, indicated power is, it's a X plan by 60 into 1000 you can take. So where X indicates the number of cylinder, okay, and a P indicates a mean effective pressure in terms of the Newton per meter square. L is nothing but a stroke in terms of a meter. Area is nothing but area of a diameter, that is a pi d square by 4 we have to take if the diameter is given, and n dash we have to take, that is a revolution we have to take. For a 4 stroke we should take the n by 6, that is the actual speed, we have to divide that by 2. Okay, this is how we can able to calculate the indicated power, brake power, and all those things. Okay, I hope you have got this. If you like this video, please comment, share it to your friends and subscribe to our channel.